Have you ever paused to ponder how lever systems play a critical role in human movement? Each time you flex your arm, lift a cup, or even walk, you're using levers. The human body is a complex machine, and understanding the mechanics of its operation, particularly lever systems, can be quite fascinating. To comprehend this, let's break it down step by step. Imagine a lever as any rigid segment that rotates around a fixed point known as a fulcrum. A lever system comes into play when two forces apply opposing torques to this lever. To apply this concept to a human body part, consider the joint axis of that part to be relatively fixed. There are two forces at work in a lever system. The force that produces the resulting rotation is called the effort force, or EF, while the opposing force is known as the resistance force, or RF. The distance from the axis to the point of application of these forces, respectively, are known as the effort arm and the resistance arm. The placement of the axis and the comparative sizes of the effort and resistance arms determine the class of the lever. There are three classes of levers in the human body. The first class lever is where the axis lies between the effort force and the resistance force. Imagine a seesaw, where the fulcrum in the middle is the axis. The second class lever is where the resistance force is in the middle, between the axis and the effort force. This results in a larger effort arm, similar to a wheelbarrow, where the wheel is the axis, the load is the resistance, and the effort is applied at the handles. The third class lever, the most common in the human body, is where the effort force is in the middle, between the axis and the resistance force. This results in a larger resistance arm. Picture lifting a drink with a straw, where your elbow is the axis, the effort is applied by your bicep, and the resistance is the weight of the drink at the opposite end of the straw. To summarize, lever systems are an integral part of human movement. They consist of a rigid segment or lever rotating around a fixed point or axis. Two forces, the effort and resistance forces, apply opposing torques to this lever. The class of the lever is determined by the placement of the axis and the comparative sizes of the effort and resistance arms. Understanding this can provide an insightful perspective into the mechanics of our own bodies and how we interact with the world around us.